All right, so this is the video for the section 2B.1 to 2B.3 notes. After you watch this video, you will have right underneath the video in the announcement, there'll be a QR code or a link, whichever way you want to do it, to go and do a individual Kahoot. It's just a couple questions to just help you see if you understood what you watched in the video and to let me know kind of, yes, you completed the video and you're showing me that by finishing the Kahoot. So we're going to go ahead and get started. So remember, this is for the class that we're not having this Thursday because the college is closed for the holiday. And since we can't have class, I have to make up that material. We do not get another day back added at the end of the semester. So we're looking at 2B.1, which is a pretty short section, mainly because a good bit of it is covered in the pre-video that you should already be watching. Remember the WWW assignments each week for the Thursday class we would have had. So we're just going to pick up and do a little bit of just recapping on 2B.1, mainly because it is just covering these three situations that we want to talk about in statistics, which if you have a set of data, you want to know if you can find the mean, which is another word for average, the median, which is the middle value of your set of data, and the mode, which is the number that occurs the most. So let's look at this example. It says, Susan randomly selected a sample of plants to determine the average height of the total 35 plants in her garden. So she has a whole garden of 35 plants, but she's only going to measure 8 plants and see if she can get an idea of what the rest of the plants might look like as well. So here's the one she did. She got a 2.5, and this is all in inches, 3.5, 4.2, 4.5, 4.8, 5.3, 6.0, and 6.2. So we're looking at the mean first. So let me get my ink. So the mean is just found when you have a list like this, you are just going to add all the values together. And we usually use when it's a sample like this, because we are only doing 8 of the total group, we use this little symbol called X bar. That's how you read that. That means it's the mean of your sample. So we're going to add all of those together. We want to know what that total value adds up to. So I'm going to show my work so you see how I get the answers. So we're going to add them all together. So just write that out. And then I'll get the total for that top. And then we're going to divide by how many plants she surveyed, because that is how you take a direct average. That's a 6.2. So we have all of that we're going to add together, and we're dividing by the 8 because 8 is how many plants she measured. So let me get my calculator. Let's get the value for that top number. 2.5 plus 3.5 plus 4.2 plus 4.5 plus 4.8 plus 5.3 plus 6 plus 6.2. That adds up to a 38. And sorry, did I say 30, 38? 37. 37, and we're going to divide that by 8. Trying to talk all at the same time. So that's going to be 4.625. And there were no rounding directions, so I'm just going to write that out. 4.625. So that would be the average height in inches for those plants, those 8 plants. Okay. Now, the median is a little different. First of all, you have to have, and I'm just going to abbreviate this as median. We don't have a special symbol for it in this class. You do if you take statistics, but we're not going that deep into that. So the median, MED, has to be the middle. So to find the middle of the set of data, first of all, your data has to be in order from least to greatest, which we are given least to greatest. If you actually double check, the whole list was given to us already in that order. If it's not, you need to rearrange your number list from least or smallest number all the way up to largest. You want to make sure they're in order. That's the only way you're going to find the true middle. If you have an odd number of items, which we do not, we have 8, we have an even set of numbers. If you had an odd set of items, you would find that the median is exactly the middle number. You'd find one number in the middle of everything. If you have an even set, which is what we have 8, see 8 different data points. There's going to be 2 numbers that fall in the middle. So if you notice, it's right here. It's between 4.5 and 4.8. So kind of like if you think about these 2 guys being the middle numbers, the median is actually going to be somewhere halfway between those 2 values. Okay, so this splits the data into 4 to the left and 4 to the right. So when you're doing an even set, you have to average the middle 2 numbers after you get them in order. And that's only if you have an even set of data. If you had an odd set of data, you would have one direct middle number. It would be the number that splits the group in half on each side. So since we didn't have that, we had two numbers in the middle because our split's kind of in between them. We're going to add them together and cut it in half. And that number, even though it's not a number in our list, that's technically where the middle would be. So 4.65. Okay. And then the last type is the mode. The mode is the number that occurs the most. And you can have a couple things go on with mode. If you have no repeating data, you don't have a mode. And that's what we have here. We don't have any plant that had the same height as any of the other ones. So we would write no mode. So if every single value is unique and different than all of the other ones in your list, you have no mode. If you have one value that's repeated more than the other values, so say I'd had two 4.8s instead of the 5.3, let's say that's also 4.8, then I would have said 4.8 was the mode. It occurs more than everything else. If you have two different values that both repeat the same amount and they both repeat more than everything else, you can have multiple modes. So mode can be none, a single value, or multiple values. It just depends on what is the most repeated value. Okay. All right, let's look at number 2 here. It says a university administrator is interested in determining the mean salary for all 50 advisors at the university. To calculate the mean, the administrator adds all of the salaries together, so they're telling you how to do an average, and divides by the number of salaries, which was 50, to arrive at the mean salary of 54,000. Is this mean salary a sample mean, which means they did not use the entire population? Or is it the population? They did use everybody in the group. Well, since there were all 50 advisors and they're telling me that they added them all together and divided by 50, they did not do what we had Susan do. Susan said, I have 35 plants, but she only measured 8 of them. She did a sample. Since we are taking all 50 of the advisors and using every single one of their salaries, then to get the mean of the salaries for the advisors, we would say, yes, this is the population of our entire university since all 50 advisors were used because they only were looking at advisors. Okay. So this would be a population mean. And then this symbol right here is just to show you, this was if it's called a sample. This little guy right here, this is a Greek letter. And if you're talking about your population mean, which this is how you tell your audience that you're using all the data that you have for that group, not just a part of them. You say, I got mu for my mean. Mu means, this is a Greek letter, it means the population mean. Okay, so it's just a symbol, but the main thing is recognizing that that is the population mean since they used all 50 advisors, all of the people that they were concerned with. Okay. All right, now we're into 2B2. So 2B1 was pretty short because, like I said, it is really just making sure that you understand what was covered in that WWW assignment. Okay, so make sure you're watching those videos this week as well, because that does more with the averages and stuff. 2B2 is weighted averages. Now, this right here, you want to put a star by this when you take your notes. This is what you're going to want to fall back on when you're looking at Project 1. Project 1 is all about a weighted grade book and a GPA calculation stuff. So it has everything to do with this specific section. So it says an average is a measure of the center of a data set. You calculate the average by adding together all the data points and dividing by the total number of data points. So that's what we were doing when we were finding like the averages of Susan's plant heights. Each number counted equally in the calculation. So in some situations, we don't want each thing in our data set to count equally. For example, like your Math 123 grade book. We don't add Kahoot questions at the same weight, like our Kahoot assignments. Say you do your Kahoot in class that day, that is not weighted at the same percentage towards your final grade as, say, a quiz or a final exam. Okay, so in a weighted average, some numbers or some categories count more than others towards your final grade or final value. They carry more weight. So we're going to show you two types of weighted averages. One is by counts, which is kind of how GPA works. It is how GPA works, but I'm going to show you that. The other one is category percents, which is how our Math 123 grade is calculated. It's a weighted by category percentages, essentially. So like exams are worth a certain percentage, quizzes are worth a certain percentage, and so on. Now, this was pulled from some of the Newton stuff. I think sometimes it's a little harder to read all of this and actually understand what it's telling you to do. So I like to more just kind of give you a summary, And then we're just going to jump in and do it because this kind of tells you how to design a table, but a lot of times you'll already have a table in front of you. So let's just read this right here. Weighted averages by counts. You have a variety of items or data worth different values. So like GPA, grades are worth different values, like letter grades are. The frequency of each value is the count. So how many of each item do you have? Instead of listing each data entry item individually, we group them by the common value to save time and be more efficient in calculating averages. Okay, so like I said, you can read through the bullets, but I'm just going to jump in and show you an example. So look at this example right here. I've already kind of pre-set up a table for you. Now you may or may not always have this in Newton, but it's really easy to calculate and put this into a chart for yourself. So there will be some where we make the chart ourselves too, but we want to start easy. So it says a bank wanted to understand the customers who are applying for mortgages. Throughout 6 weeks, the bank collected the data depicted in the table below. This data will help them better serve their customers needing a mortgage. Now, I'm going to underline this next sentence because it tells you why I'm treating age as the value and the applicants as the count. They asked me for the average age of a customer. So the average age tells me I am valuing the customer's ages. Okay. So that is our numerical value. These are like our data points. So notice if I wanted to list this data out the long way, which I don't, this is really kind of what we call a frequency table. They're telling you that there were 5 people who came in who were 30 years old. So if you were to list out the data set, you'd have 30, 30, 30, 30, 30. There's 5 of them. Then we move to the next age, 31. There's 7 of them, and so on. So I would just keep listing out until I've met this number of applicants for each age. That would make our list extremely big, and we don't want to try to take the average that way. So we're going to use the fact that they've already simplified the table for us. They're telling us you have 5 30-year-olds, 7 31-year-olds, 6 32-year-olds, and so on. We can use that to really quickly get the sum of all the 30-year-olds, the sum of all the 31-year-olds, and so on. Okay. So we're categorizing them by their age, what we were trying to average. Okay. So to get this total value per category, which would be our ages, we just multiply. If I were to add 5 30s up, that's the same thing as doing 30 times 5. So that would be 150. So that's the 5 30-year-olds combined ages. Okay. Then we're going to do, I'm going to use my calculator. So we're going to do 31 times 7. That's 217. We're just going to make this list as we go down. Then we have our 32-year-olds. We had 6 of them. So that'd be 192. We had 12 33-year-olds. So that's 396. We had, for our 34-year-olds, we had 21 of them. So that was a big group. So that's 714, which makes more sense. You know, as people get older, they might be more financially stable and ready to apply for a mortgage. 35-year-olds, we had 17 of them for our applicants. So that's 595. Okay. So this is the combined total age group values. Like, so we've added up all the 30-year-olds, all the 31-year-olds, and so on. Okay. If you add all of these total values by category together, you will have the total sum of all of the ages of all the customers that they saw. So that's 150 plus 217 plus 192 plus 396 plus 714 plus 595. So I'm going to write that down right here. That's 2,264. So remember, this is a sum of all their ages. Now, we have to know what to divide by. Well, we can't just divide by how many ages did we have, because remember, this list is not just one 30-year-old and one 31-year-old. There are repeated 30-year-olds, repeated 31-year-olds, repeated 32-year-olds. So we need to add up the total counts. This tells me how many applicants in total did we have for all of these groups, okay? So if we add that together, 5 plus 7 plus 6 plus 12 plus 21 plus 17, that is 68. So notice you have all of your ages added together. That's going to be our top part because we wanted to average the ages. We wanted to know the average age. We're going to divide that by how many applicants were we looking at, which was the 68. So this is the average by counts. Okay. So 2264 divided by 68. It's going to be roughly, did they tell us? Yeah, round to the nearest whole number. So this is 33.2. I'm not looking at the 9 right now, but we're looking at rounding to the whole number. So that's the 3. So if you look behind it, it's a 2. A 2 does not bump up a 3. So this would be roughly 33 years old per applicant. Okay. And if you look at this, that kind of makes sense. There are some people younger. There's a lot of people just a little bit older than that, the 34 group, but we had enough people in the lower age groups to keep us from going too high. We're kind of we're probably somewhere in between the 33 to 34-year-olds. And notice that kind of is in between the number of how you see the spread of the data. Okay. Doesn't have to be dead middle because remember, this is an average, not the median. Okay. All right, let's look at another one. We're going to make the chart ourselves this time. So we said a lady knits scarves, gloves, and hats. She sold 30 scarves for $18 each, 28 pairs of gloves for $15, and then that's for each. And then for 40 hats for $25 in November of last year. So these are all the prices for each. What was her average sales price? And they even tell you per item. So they're telling you we're averaging the sales price per item. So this is our value. The value is the sales price. Okay, so our value is what money we are making. The counts is going to be how many we sold in each group, because you have to actually know how many you sold. And then we'll get our values by categories. And you don't have to label this with all this. This is just to help me do this in my head, okay? All right, so I'm going to just make a little key for myself over here. We have scarves, gloves, and hats. Remember, those aren't actual numbers. That's just to help me put the information here. So the scarves were $18 because we're averaging the money that we made. The gloves were $15. The hats were $25. Okay. And we sold 30 scarves. We sold 28 glove pairs and we sold 40 hats. Okay. So if we multiply all this together, we're going to get total value of sales. Essentially, how much money are we walking away with? Because if you think about it, $18 and we sell 30 of them, we're taking away $540, okay, in our pocket just for the scarves. And then we would have 15 times 28. That's 420. And then 25 times 40. That's 1,000. If we add all that together, remember that's going to be total money that we're pocketing, okay? So 540 plus 420 plus 1,000 is $1,960. So we know that's our total sales money. But remember, we wanted to average that per item sold. So we need to know how much counts we had. That's the sold part. So how many total items did we sell? Because we're averaging it out over that. We had 98. So I added that column together. So that's going to be 98. So we had, this is how much money I made. This is how many things I sold. So if we divide that, we're going to get $20 as the average. So it's going to be average of $20 per item. And that kind of makes sense too, because notice that even though we had the lowest pricing was 15, that's the group we sold the least amount in. We sold a lot of the 25 items and we sold quite a bit of the 18 items. So we're kind of falling somewhere in the middle between those two, not exactly middle, but averaging between those two for price. Okay. But all three prices and their counts play into where this answer comes out to be. All right, I do want to make up a GPA one because I don't think I had one in the notes. I think it was in the Kahoot. So I'm going to have a second one for the Kahoot as well for you. But let's just make up a GPA one real quick. So you can just add this as an extra piece to your notes so you'll have a reference for that. But let's say, I'm just going to kind of type in a little information here. Let's say Ted took Math 123 and got a B. Chem 101 or 100, I'm not really sure what number it's labeled, and got a D. And the IVT class, let's say 100. I'm not sure what the numbers are for some of the other classes, and got a A. If Math 123 is worth 3 credits, which it is, Chem 101 is worth 4 credits, which usually sciences are worth more because they have like a lab component sometimes. And IBT is worth only 1 credit. What would be his semester GPA? Okay, so that's the scenario we're trying to solve. So again, to do this, you do have to know how we convert letter values into points. So this is usually also a direction they'll give you on these problems in Newton. They'll tell you like an A is worth 4 point values. A B is worth 3 because we're on a 4.0 system. A C is worth 2 point values. A D is worth 1 point value. And an F is worth 0 point values. Okay. So let's talk about this. So we're going to make up a little key for ourselves. We're going to have our value, which is when you're doing GPA, that's looking at the actual grade. Okay. We're going to have our counts. Your counts in terms of grades is the credits. How much did that class count towards your GPA, which is its credit value. And then we'll get our value by counts. It's the same way we did the others, multiplying. Okay. Okay, so we had math, chemistry, and IVT. So I'm just going to kind of abbreviate those. Now, the grades are B, which is worth 3 points. So remember, we're going to put the numerical value, not the actual letter grade. The D, which was the chem class, D is worth 1 point. So we're going to put that in for chemistry. And A is worth 4 points in the 4.0 system. Okay, so we had, this is the B, the D, and the A. So because we can't put in the letters, because you can't really multiply with letters and actually solve for a numerical value. So we had to give it a numbering system to rank grades as different point values. Okay, now the credits are for each class. So math 123 was worth 3 credits. Chemistry was worth 4. And IBT was only worth 1. So we're going to multiply across. So remember, this is 9, 4, and 4. Now, you're going to get that total value for the grades. That's going to be adding this up. So that's 8 and 9. So that's going to be 17. And then we're going to divide by our counts, which is total credits. And this was value by counts. Remember, you have to actually multiply to get that because you have to know how much you earned for each one total. So if we add the number of credits the student took was 8. Okay, so their GPA for that specific semester is 17 divided by 8, which is a 2.125. So that would fall in the C range, actually the low C range, because they're almost down at the 2. And usually GPA you'll round to like 2 decimal places, so roughly 2.13. And Newton will ask you to do that a lot of times in the homework. It'll say round it to 2 decimal places, or to the nearest hundredth. But the reason their GPA is so low, even though they got an A and a B, is because they made a D, which is worth very little credit point, like, or point values, but they made that in one of their biggest credit earning classes. So because that, so if this had been an A, their for the chemistry, if that had been an A instead of a D, they could have earned up to 16 point values, right? But because it was a D, or even worse, if it was an F, if it was an F, you'd earn 0 points out of the 16 possible. So they only earned, since it was a D, they only earned 4 points out of a possible 16, because the number of credits times 4, which is an A, is the total number of points you could have earned for that specific class towards your GPA. So because they made such a low grade in the biggest worth class, the biggest credit count, that is why their GPA got pulled down so much further. Because if you looked at that and you said, oh, well, they had a semester where they got an A and a B, but they also got a D, you don't always necessarily in your brain think, well, that should give you a low C for your GPA. It's because they're weighted based on the credits. And this A they made was only worth 1 credit. So it did not weight very high into their final grade calculation at all. Okay, so this is how GPA works. So I just want to make sure you had an example in the notes. You will have one like this in the Kahoot that you're going to do at the end. Okay. All right, it says Amber volunteered to work in the concession stand at a local sports event as a fundraiser for her son's soccer team. The table below shows the items for the sale, their cost, and how many were sold throughout the game. Find the average price of a for purchased food item rounded to the nearest penny. Okay, so we're going to be averaging the price. So again, they've already kind of set it up for us. We just need to do that total value by counts, and I like to abbreviate that. So we're going to multiply all these out. So 4 times, because they sold 90 of the cheeseburgers, that'd be $360 total they made from that. 3 times 40 would be 120. I don't know 2 times 76 off the top of my head. That's 152. And 6 times 45, I don't know as well. So that's 270. Remember, this is just a way to add this 4 90 times and this $3 40 times. We're just multiplying to make our lives easier since it's the same value over and over again. Okay, so we need to know our total value, which is that money. This is all the money they collected. So 360 plus 120 plus 152 plus 270. That's going to be $902 total that they collected. And we need to know how many items they actually sold. So 90 plus 40 plus 76 plus 45. They sold 251 total items. So we're going to average the price over the total number of items sold. That's our counts. So 902 divided by 251. We're rounding to 2 decimal places. The 9 is in the second decimal place. There's a 3 behind it, so it is not going to bump up. So this is approximately $3.59 per item. That was the rough average. Okay. And again, in Newton, remember, you may not be asked to put in the per item or the dollar symbol. Just look at how they want you to answer it in the directions. They may just have you put the numerical part. Okay, so that's by counts. So counts is really just like repeated numbers in your grouping over and over again. So you're just kind of shorthanding that by using multiplication instead of having to write 94s out and then add all those together. We're just using the fact that they're repeated to help us make it calculate really quickly. Now, weighted averages by percents is a little different. So each category will have a percentage weight. Category percentages must total up to 100%. Otherwise, this won't make sense because especially if like we're talking about grade book, your grade should be from 0 to 100% because that's how our letter grade system works. Now, I again use a table method. Newton uses a little different method. They have you enter everything into your calculator, but you have to be careful with that with order of operations. So I'll just show you how I kind of like to set it up. This is my general picture of what I do. I have all of our different categories. So like homework, quizzes, tests, whatever it is. We write our category weight. I put it in decimal form if I'm going to be calculating it by hand, like using my calculator. If I'm also going to show you how to do this in Excel, because that'll help you see how we've set up the template for your project. You have a template set up. You do not make the whole grade book yourself. You've got a pre-made template. You're going to be using some of the formulas I'm going to show you to average everything. Okay. But you put your decimal. If I'm doing it on my own paper and using a calculator, I put my weights in decimal form. And then remember, as a percentage, they should total to 100%. Okay. My category averages. So you don't really just have one assignment unless there's only one assignment in a category. Usually you're going to have to average. Like if you don't just do one homework, we do 20 homeworks or something like that. You know, if you're doing multiple items in a category, we put the average for that category there. Okay. We do not put that in decimal form. So we're just saying, like, if you got 92% for all of your homework at the end of the semester, like say that's what your average is, you'll just put 92 here. Okay. You multiply the decimal form of your weight times that average, and that gives you what we call category percentage points. PPTs is what I like to call them. That is how many points out of the possible weight. So if it was a 10% weight, you could earn up to 10 points, percentage points towards your final grade. So how many of those points did you earn? And then we sum all those up. Now, the thing about this that's lovely is that because when you have your percentages in decimal form, the weight is a 1 because all those decimals will add to 1, which is the same thing as 100% if you leave it in percent form. Okay. So you really don't have anything to divide by here because you're dividing by 1. So luckily for weighted averages, as long as this adds to 100%, You just have to sum this, and that's your grade, okay? So it is a little different than what we did for the counts. So let me show you an example real quick. A syllabus shows that tests are 60% of students' grades. So I'm going to write my categories. I'm going to go ahead and make my chart here. Categories. We've got test. Okay. We have homework. I'm going to abbreviate that. We have projects. Just looking at all the categories they gave us, and we have quizzes. Okay. Now we have our weights for each one. And again, you can write them as percentages if you want, but when you go to do it on a handheld calculator, unless you know where your percent symbol is, you need to make sure they're in decimal form. So this one would be 60% would be 0.60. So remember, that's just moving the decimal 2 places to the left. Homework was worth 10%, so that'd be 0.10. Projects are worth 20%, so that'd be 0.20. And quizzes are worth 10%. Now notice that adds up to 80, 90, 100. Yeah, if you think about them in percent form, that was 100%, or it adds to a total of 1. Now we have our category averages. Okay, these are the person, these are everyone gets these weights. The whole class is held to this system of weights, but we have a specific student and this is their grade. So they got 58%. We're just going to write as 58. We do not convert these to decimal form. This is how many points out of 100 essentially that student averaged in that category. So these are like our points. Okay, so we got 58 and then we had 98. So they did really good in homework. Maybe didn't do one of their projects. That's the only way I could think you'd have such a low percentage on projects. And then 87% on quizzes. Okay. So our percentage points are calculated the following way. You are taking a percentage of the average. So it's 0.6 times 58. So out of a total of 60 points, remember, because that's 60 out of the total 100% you can earn on your final grade. This person earned 34.8 of those percentage points. So not great, not horrible, but just a little over half essentially of what they could have earned. Because they could have earned, if they had 100% on test as their average, they would have earned all 60 points, okay, towards that final grade. And then 0.10 times 98. So they had a possibility of earning 10 percentage values towards their final grade. So out of 10 possible total points towards that final grade, they earned 9.8 because they got a good average on this. So that's good. So not really much they could have done, not much they could have done to improve that category. Projects, this is one where they maybe, like I said, missed a project. They got a 32 as the average. So out of 20 possible points, they left a lot of those on the table. They got only 6.4 of those towards their final grade. And then 0.10 times 87 is 8.7. So again, 10% would be 10 points towards your final grade as percentage points. If you made a perfect score, they earned about 8.7 of those. So now we just have to sum those up, and this will be the grade out of 100 points that they're going to get, because again, we're out of 100 percentage points that they would have gotten. So 34.8 plus 9.8 plus 6.4 plus 8.7. This person would have barely rounded to a D, 59.7. So if your teacher rounds, this is their grade. If they ask me what their letter grade is, I would say it would round to a D if, because we do round in our class. If that's a 0.5 or higher, that 59 would bump up to a 10, and then that would bump that up to a 6. So in our class, this person would have gotten a D. But if someone doesn't round, if they say, nope, you get what you get, I don't do any rounding, then that person would have got an F. And most of that could have been avoided by making sure they did the project, both projects, and maybe getting a little help studying for the exams, because they did pretty good in the other two categories. Okay. All right, let's look at a different one. Now, this one's not out of 100 points. This is out of a scale from 1 to 5. If you've ever taken one of these surveys, the Likert scale is where you say, I strongly disagree is a 1. Then you'd be disagree would be like a 2. Neutral would be 3. I agree with something would be a 4. And 5 would be strongly agree. So it's like you're ranking based on feelings or emotions about something. Is it a 1 to 5? Okay. The table below shows the results of a recent survey. Use this to calculate the final score out of 5, not out of 100, for this survey question. So we work this the same way, essentially, as long as this still adds up to 100%. So let's double check that. So 3 plus 13 plus 21 plus 23 plus 40. Yep, we're good. And all of ours should work out to 100%. We're not going to give you anything weird. So I'm going to go ahead and write all these as decimals because these are our weights. Okay. 0.21, 0.23, and 0.40. These are our values. These are the actual rankings. Okay. So we're multiplying 1 times 0.03. That would just be 0.03. And then we do 2 times 0.13. That would be 0.26. And remember, what we're going to add this up to is should be a score between the 1 to 5. Okay, so it shouldn't add up to 100 points like, our grades do, because the max you could report it on this was a 5. 3 times 0.21 is a 0.63. And then 4 times 0.23 is a 0.92. And 5 times 0.4 is a 2. So 2.00 if we want to line those decimals up. So if we add this together, this would be the average score between 1 to 5 that they were seeing. So 2 plus 0.92 plus 0.63 plus 0.26 plus 0.03. So it looks like an average ranking of 3.84, which is not too bad because, a 4 is you agree, a 3 is your neutral. So we're closer to agreeing, but we're still kind of in between neutral and agreeing. Okay, so that's what their kind of the feeling is from that survey that they put out. All right, so let's look at, now this one I'm going to do in Excel just so you can see how to, not that you're, like I said, you're not going to create a grade book from scratch. You're going to have a template already given to you. You're just going to show me how to use some of the formulas that I put in bold down here. Okay. So let's take this data and let me pull up my Excel and make sure I'm doing still a full screen share. Yeah, you can see that. I'm going to split this into 2 pieces. Okay. And we're going to look at, let me zoom that Excel in because it's super tiny. We're going to look at how to work with this. Okay. So what I normally do if I was setting it up myself, which like I said, on your project, you're given a template, you're not setting it up yourself, you're just going to be filling in some of the formulas. But we would normally put our categories as kind of like a chart. So we have test, we have projects, we have quizzes, and we have homework, okay? And when you open your project, like I said, your template will already have a lot of the grades you're going to be using. You don't change them to your grade book, like in the actual Ivy Learn. We're all going to use the same made up student, okay? So, but this is just a pre-example with a small set of data so you can see how to run through some formulas. So we have like a 50 on a test, an 85, and a 90. Now, this obviously wouldn't be Math 123 because we don't have the exact number of tests and projects matching like they do in our class. This person had projects. They had 3 of them. They made a 5, a 95, and a 70. For their quizzes, they had a 90, a 95, an 80, an 87, a 77, and an 85. For homework, we had 100, 100, 100, 100, and then an 80, a 50, a 100, a 90, and a 98. Okay. And then down here, I'm going to have Excel. So on your template, this will be the first thing that you would have to do on the pre-made template. You're going to have to take these groupings, these categories, and you're going to average them. But you're not going to do it on your own calculator. You're going to use the formula for Excel for averaging. You just type equal sign. That's how Excel knows that you're telling it to use a formula. You type in the word average. You can see that it auto-populated it as I was typing it. You just want to click the one that says average, not average A, average if, none of those, just average. And then you can either highlight with your left mouse button clicked the cells that you want it to average, or you can type in the cell name. Notice it says B4 colon B6. That says I want you to average everything from B4, so notice column and row, to B6, okay? And you can close that parentheses if you want, but if you go ahead and hit the enter button on your keyboard, it will go ahead and know that it wants you to average it, okay? So that's the average. And you could double check that on your calculator, but we want it to be a formula in Excel because if I change one number, if I say, oh no, I typed the student's test score in, it was a 60, boom, the average update. I didn't do anything but fix the test score and the average still works. Okay, that's what we're looking for. So please, please, please on your project, do not go off to the side with your calculator and do these in there and then just type the number here. You need a formula so that I can make changes if I wanted to and see if your formula still works, okay? We're going to do the same thing for this one. Equals average. I'm going to have it do those three. This next group is a little longer, so make sure you get the whole group. We're averaging all of these. And again, I don't want it cutting off these decimals. It's giving me the long repeating decimal. It's just, it does look like it truncates it, but if you actually widen your cells, which we won't ask you to do, it still knows it's calculating that out further, okay? And then this one is right here. Okay, so I have all my averages, okay? Now, I'm going to have a little grade book. Now, yours will probably be all, since I don't have the ability to scroll very easily here, I'm going to put mine right underneath, but I think your pre-made grade book will be over here to the right of this. So again, use the template we give you. So this is going to be for the grade. We're going to have the weights for each group. We're going to have our averages, and then we're going to have our percentage points, okay? So those are like the titles. This is so that I don't need the grade written there. I'm going to put it down here at the bottom. But let's get our categories weights lined up first. Now, on Excel, you don't have to turn these into decimal form. You can just type in the percentage, but make sure you put a percent symbol. Excel will only treat it like a percentage if you put that symbol there. So 60%, 20% for projects in that specific class. And I might put my category names again. That might help. So test, projects, quizzes, homework, okay? The quizzes were worth, I'm looking over at the problem, 15%, and the homeworks were worth 5%. So I'm just looking at the description here, okay? Now, you do not want to manually type in these numbers because then you're going to be cutting off those decimals. If you just want to copy a cell so that it will move the value without changing it, you can just do equals and click on the cell. The reason I want to do that is if I change something again up here in the actual scores, it moves it in both places to the correct value. Okay, that's what we mean by everything should be connected. Okay, so I'm going to do equals and then this one. Equals and then this one. Equals. Oops, did it in the wrong place. Let me hit that again. Equals this one. Okay. Now, if you didn't have this row with all the averages, you could have put your averages here and use the equals average type in. And I think that's how we have it, you doing it on the video. Make sure you watch the project video. It's really helpful. It will not have exactly the same numbers or percentages. Sometimes we change things up from semester to semester, but it's a guide to help you get to the right place. Okay. Now, for the percentage points, again, we don't want to calculate it in our calculator offline and then just type a number in. We want to use a formula. So equals, all you have to do is percentage, and then you have this little button. If you have your number keypad, or if you have just a keyboard regular pad, it's like a shift and your number 8. On the numerical part, it's above the 9. This little time symbol looks like a star, okay? And then times this, and you just hit enter. Equals this times this. So you're just having it do that multiplication. And you're not worried about it rounding things incorrectly because it has the whole number still connected here. Equals this times this. So there's all my percentage points. And then my final grade would be to sum all of these points that they earned, their percentage points. So equals sum. And then we highlight all of those. Okay, so this person would have gotten a C. So the final grade is about a 73.7, depending on what they tell us to round to. And then that would be a C on our grade scale. Okay, so this one right here, I don't really want to write anything over here. I just wanted to show you a visualization of how you can use Excel formulas of average, multiplying two cells together, and then summing. Okay. So make sure you follow. Now, again, this one's not a carbon copy of your project at all. Just make sure you look at the template we give you and follow the directions when you start looking at it. That is how you're going to set up your formulas. You want to do it the way we have it set up in the pre-made template. Okay. You're not making a template all by yourself. You're just plugging in some of the formulas. Okay. All right. So let me make this part big again. So that's the end of 2B2. So we have our last section, which is 2B3. And I do need to make a slight change. These notes, Newton made a change to how they are doing this part. So Let me make sure I have this up. There we go. They no longer require, because they used to force you to make your absolute change always positive. They no longer require that, so you don't need to worry about these little absolute value symbols. Um, and I will mark out the little piece down here that talks about that. So just in your notes, you don't need those little absolute value symbols. So we're going to be doing absolute change, relative change, and percent change. So absolute change is just, you're going to be given two values. Like, so say I used to make $30,000 and now I make $40,000. The initial value is your starting value. The ending value is your final value. So if I wanted to know my change in salary, I'd do my new value, which was the 40,000 minus the 30,000. Okay. And I'd say, oh, 10,000 is a positive number, right? Just naturally. I could say I have an increase of $10,000 to my salary from whatever date to whatever date, however long it took me to accomplish that. Relative change is the decimal form of what we're going to really be focusing on, which is percent change. So you take that absolute change and you always divide it by the initial value. So like I said, if my salary went from, we're just going to write this down. We said from 30,000 to 40,000. So let's say this was our situation. We already said that the absolute change of that would just be the new value minus the old value. And on this one, you can put units. This would be an increase of $10,000 because it went up, not down. From to, this is like a lot of other times we use for from is the old value and the ending value is the new or final value. Okay. So from my old salary to my new salary, I increased $10,000. Now, the relative change means you take that absolute change you just found, which was $10,000 that was positive, you divide it by your initial salary. So that was 30,000. What this gives you is the decimal version of the percentage. It's the decimal form. Okay, so this would be 0.33 repeating. So I'm just going to write out like a bunch of those and then dot, dot, dot. Okay, now if we times that by 100, that'll put it in percent form, which would be 33.3. A lot of times you'll have them, they'll have you round at the end after you've done the times by 100 to the 10th of a percent. So since it's just threes forever, it's just going to be 33.3%. And again, this is increased because we went from a low value to a higher value. Okay. So notice I said the words new and old are sometimes used instead of final and initial. When we're putting these values into meanings for real life situations, we usually talk about you either have more than what you started with or less than. Okay. This will be done in the objective on interpreting percent change. This is what I said you can mark out. I didn't know where the line was. Because Newton changed this to match with the correct format, they used to force everything to be positive, and then they only would let you put in the word increase or decrease as a drop-down menu. They still have some of those questions. So if you have a drop-down menu where it says increase or decrease, the increase means you got a positive number. A decrease means you had a negative value for your absolute change or your percent change. But now they let you have the point where you can actually, if you get negative for your absolute change, you actually can type it in as a negative absolute change, and that is going to mark it correct, which it should have always. We had to talk to them about how we didn't like how it was set up. So you can completely ignore that little statement that I had there, okay? Which is, again, it kind of leads into this right here. They're not always going to be positive in Newton anymore. It's just if they ask you to tell them more or less than, or increase or decrease, the increase or decrease is telling you if something is positive or negative, okay? And this will play in not with project 1, but project 2. So we will touch back on project 2 after the midterm. We'll talk about what you're going to be doing in there. It's a financial project. After you do some of the calculations, you write a sentence where you tell someone, oh, well, my salary increased by $10,000, or I make $10,000 more than a high school student. Okay. So you'll have some statements that you can write about that. So we're just going to like practice one. And like I said, I'm going to have to erase these little absolute values. So if you printed your notes, don't write them in or mark them out. If you didn't print and you're just writing, don't put the little absolute value symbols. Okay. All right. So, and they're everywhere. Unfortunately, I did not catch this in time to change all the note templates. But I'm glad they made the correct change in Newton. So it says tuition was $1,200 last quarter and $1,500 this quarter. This is a $300 increase. So that's the absolute change. So if they're saying from last quarter, which is the old one, to the new one this quarter, and they didn't tell us to do that specifically, but I'm showing you if we were going that direction. So we're going from last quarter to this quarter. Okay, so this makes this one the old and this one the new. So you do your new tuition minus your old tuition. That is an increase of $300. It's a positive. Then we would divide that by the initial tuition. The original tuition was 1,200, so that comes out to 0.25. Percent change, remember you multiply that answer by the 100%, so you get 25%. So I just showed it with all the formula details. You really don't have to show all this. You can literally just move the decimal 2 places to the right and say it's 25%. So if we interpreted that, that would be tuition this quarter is 25% more than tuition last quarter, okay? Now here's something about absolute change and relative change and percent change that can get students. The order I did it in this time was from last quarter to this quarter. If you change that, it is not also going to still be 25% decrease. It's not going to just go the same percentage the opposite direction. It is not reversible. So I'm going to show you that we're going to take that exact two values that we did, and we're going to change the order this time and show you that you get a different percentage, okay? So consider the situation below and find the absolute relative percent change from this quarter now to last quarter. So they're now treating the newer quarter as the original statement and previous quarter as the new statement, because this is always read as from the old to the new. It doesn't have to be the same chronological order. However they say from and to, the from is always the old, the to is always the new, okay? So if we're doing it this way, this time last quarter is the new. So absolute change is supposed to be new minus old, okay? So we'll be doing the last quarter is new, so that's going to be 1,200. We're treating that as the new value, minus this quarter, which is our from. That's going to be the 1,500. This is when you get a negative. We reverse the order. So now we're saying, oh, in that order, if we're comparing this quarter to last quarter, we're saying there was a decrease in tuition if we go back in time, okay? So that's why it's negative. The relative change is you take that number and you divide it by the initial. The initial this time is your old. Old is always initial, so that's this quarter. So that's the 1,500. So this is why you get a different percentage when you change the order of the new and the old, okay? It's because you're dividing by the old. We always divide by old. So relative change is always new minus old divided by old every single time. So when we do that, that's 300 divided by 1,500. And I know it's negative, but I'm just getting the decimal. So that's negative 0.2. I just didn't type in my negative symbol. Now, if I want to make that a percent, I move the decimal 2 places to the right. So it's negative 20%. So notice when you change the order, it's no longer 25% increase. Now it's a 20% decrease. And this is something they can really get you in. So on this, you don't have to write the negative symbol, and I'll tell you why. They use the word less. Less means negative in vocabulary, okay? If they wanted it to be a positive answer, they would have had the word more there, okay? So the tuition last quarter is 20% less, so that's where you're telling us it's negative than this quarter, okay? So big thing that they'll get people on is thinking that the percentage, if you change the order of the new and the old, the percentage stays the same. It does not. For example, if someone at work told you, oh, well, we have to reduce everybody's salary by 10% because of budget cuts, but don't worry, in 5 years, we're going to increase everybody's salary by 10%. You did not gain back the original salary you used to have. You would still be shy of that. So say, and I'll show you what I mean by that. So like say you were making 50,000 and they told you, oh, we got to cut everybody's salary 10%. So you're going to lose $5,000 off of your salary. So now you're making 45,000. Okay. And then they say, okay, we're freezing everybody's salaries for 5 years, but don't worry, guys, we're going to add that 10% back. But they're adding 10% of this salary, your new base. They don't tell you that. So it's times 0.1 or 0.10. You're missing $500. So you'd still only be making 49,500, you would not be back up to your original 50,000. So the percentages do not work the same way because they're based off of the old value, the from, not the original or the new value. They're always based off the initial value. Okay. So if you're basing it off of your base that you're currently at 45,000, not the 50,000 you used to be at. Okay. All right, now let's try another one real quick. It says in Orchard Park, New York in 1990, 238 inches of snowfall were recorded. In 1991, 198 inches of snow. So we're looking at measurements of snow. Find the absolute and relative change and also probably percent change of the recorded snowfall. Now notice here they told us to go from the 1990 to the 1991. Now that doesn't mean we're going to be adding and subtracting with the years. We're still measuring snowfall. So 1990 is the old snowfall. 1991 is the 2, so that's going to be the new snowfall. So when I go to do absolute change, I do new value of snow minus old value of snow. Okay, so we've got 198 minus 238, that's negative 40. We want to get that as a relative change. We take that value and we always divide by the old. So the old is the 238. And I'm going to write this out to like 6 decimal places first. And I'll go ahead and make it negative since I forgot to do that. It is, now I'm going to write this out to, like I said, 6 decimal places, negative 0.16806. I think there was a 7 after that. And then I'm just going to put dot, dot, dot. Because we are not rounding yet. We're going to round to the nearest 1/10 of a percent. So we're going to change this to percent form. So move it 2 places to the right to make it a percent. This is going to be negative 16, and the 1/10 of a percent would be 16.8 because the 0 behind the 8 does not bump it up. Okay, that's our decrease. Now, this is what I meant by you don't always have to write the negative symbol in the sentence part. I did write it in my answer part. Like these are definitely decreasing snows. But we're going to put the word decreased to represent that. So you have like a drop down menu on your homework and you choose decreased. Okay. The snowfall decreased 40 inches. So I didn't have to write negative 40 because the word decrease is telling me it's a negative 40. Or, and again, I don't need to write the negative since we said decreased. It's decreasing 16.8%. And I don't know why they have you fill this one in, but this was just restating this statement from 1990 to 1991. Okay. All right. So I believe I had some of these as the Kahoot. I had removed some of the ones in the 2B.1. So what I want to do on this is I'm just gonna I'm gonna do every other one, and I'll make sure the Kahoot has the ones we skipped over. So just make yourself a little note that you can fill these in as you do your Kahoot. If anybody wants me to give, well, you'll get the correct answer. If you answer the Kahoot, it will tell you the correct answers as well once you've entered them in. But I'm going to do every other one just because this video is getting a little long already. So it says, in 1 year, after several major back-to-back destructive hurricanes hit the area, the median home price in one Florida town fell. So it went from this to this, and they actually gave us the prices here. So they put them exactly where they need to be. So this one's the old, and this one's the new. We want the percent of decrease. So we need to go all the way to the percent change. And we know it's going to be negative already, okay? Because it says decrease. So new minus old divided by old. That gives us the relative change. And if you times that answer by 100%, once you're done with it, that gives us the percentage. Okay, and we're going to end up rounding it. So I'm going to work this out. So 206,300 minus 308,400 is negative 102,100. And then we're dividing that by the original housing price, 308,400. Now I'm going to write this out to, like I said, about 6 decimal places. So it's negative 0.331063, 5, and then dot, dot, dot. But we're going to times this, remember, by the 100%, or move our decimal 2 places to the right. So that's going to be 33. It's a negative 33.1%. Nearest 1/10 of a percent means after you're in percent form, then you round to 1 decimal place. Okay. You cannot do it here. You can't round this to 0.3 and then say, oh, that'd just be negative 30%. Nearest 1/10 of a percent means you don't round until you're already in percent form. So you have to move the decimal the two places to the right or multiply that by 100. That's essentially what you're doing. Okay, let's look at another one. So it says an employee receives a pay increase from 35,000 per year to 37,500 per year. So this is the old because it has the word from. This is the new. And we're calculating the percent increase. They increased in their salary. So the new minus the old divided by the old. And then remember, you're going to times that by the 100% to get the percent increase. Okay, so we're doing that percent change formula. So the top's 2,500 divided by 35,000. I'm going to write the decimal out first for myself, 0.07142 and dot, dot, dot. You could go a little further if you want, but you really just need to make sure you have at least 5 decimal places if you're rounding to the nearest 1/10 of a percent. So move this 2 places to the right. That's the timesing by 100. That's going to be 7.1%. That's the increase. And it's a positive since we had a positive for the new, or a positive when we did new minus old. Okay. I'm also going to make sure 15 is on the Kahoot because I want to make sure we just do this last one down here. So again, these three, I didn't tell you what's going to be on the Kahoot in the other sections because I had to create new problems. There weren't enough to pull from. But for this set of notes, I had some of these already predisposed as Kahoot questions. But I don't want this one to be a Kahoot. This one has some interpretations that we need to make. So it says, according to the U.S. Bureau of Labor Statistics, the median salary in 2021 of a dentist is $163,220 per year, and a vet is $100,370. So that's average or median, so middle salaries. For percent change, round to a whole percent. So we're going to round to a full whole percentage, not a decimal. Okay, find the absolute change. Now look, from dentist to vet. So we're treating the dentist as the old in this one. Okay. So the dentist is that, the vet would be the new. So we're going to do new minus old for absolute change. So $100,370 is the new minus one. And that's because of how they told me to do this. They gave me the from and the to. So we're subtracting the dentist from the vet. Okay. So we've got 100,370 minus 163,220. That is negative. So we have a negative $62,850 difference. Okay. So find the percent change from the dentist, or excuse me, from the dentist to the vet. Same ordering. So we're taking that absolute change and dividing it by the old. Always divide by old. So that's by the dentist because you're basing that as your base. Okay. So we're dividing this by the 163,220. And I'm going to write that out to quite a few decimal places. It was 0.385. Excuse me. Allergies and dot, dot, dot. They wanted us to round to a nearest whole percent. So move your decimal 2 places to the right and notice this is 38.5. So that would round up to 39. So this is a negative 39%. Okay. Now we're going to write a sentence using these results. Now there's 2 ways you can write this. You can write it using the absolute change, or you can write it using the percent change. So the first one is, and again, when you write these sentences, because this is going to help you in project 2, you always start with the new reference first. You'd say the vet makes, and now you're going to say a certain amount more or less, depending on which way our sign is going, than the dentist. So they make 62,000. Notice I'm not putting the negative here because I'm going to use the word less than the dentist. Okay. The new makes either more or less. You have to tell me which way it is based on the sign than the old. Okay. The second sentence is the same exact format. You just use a percentage instead. So the vet makes 39% less than the dentist. That's it. Okay. Now we're going to change the order this time for part B. We're going to do from the vet. So now we're treating the vet as the old to the dentist. So that's now going to be the new. So to find the percent change, remember you do new minus old divided by old times by 100%. Okay. So the new is the dentist. So that'd be the 163,220 minus the vet, which is 100, 370. The vet is the old, so that's what we're dividing by. So 100, 370, it's our reference one. And then we would do our times by 100 after we get that. So 163,220 minus 100, 370. Notice this is the same answer we got up in part A, but it's just positive now because we changed the direction. But the difference comes in when you divide by your old. You're dividing by a different value because we're referencing a different value as the old. And so this one rounded to the nearest, so times that by 100, rounded to the nearest whole percent would be 63, I believe. Let me double check that. Yeah, 62.6, so 63%. Okay, and that's an increase. So we're going to write it a result using D. Okay, so we would say, now it's the dentist is the new this time. So the dentist makes, and we only had the percentage this time, so 63%, oops, more, since it's positive, than the vet. Okay, why are B and D so different? The difference of referencing the vet or the dentist as the old value is what changes the percent increase or decrease amount. Okay, so it's that referencing the old value differently. We're viewing it in a different order or direction. Okay, all right. So that is the end of the video. Hopefully that wasn't too bad. You need to look right underneath the video in this announcement. There'll be the QR code if you want to use that, or a direct link with a little PIN number you can put in. That will get you into the Kahoot. It's definitely going to have these 3 questions I skipped over in the notes. So make sure you look at those. And like I said, the Kahoot will tell you the correct answer on those once you've submitted your values, I believe. So once you've done that, you will also have a few questions that I've created from the other 2 sections. That's how you, and make sure you put your name on that when you do it, when you sign up as a player. That's how you will prove to me that you watched the video for today. So like I said, you don't have to do it on Thursday. Thursday is a closed day for the college. It's a holiday. You just need to do it before your homework and things are due for that section. Okay. All right. Have a wonderful rest of your day.